gives us a similar setup to question 1. 3 different states of the economy, 3 different probabilities, and different returns for stocks A, B, and C. So if we have a particular portfolio rate, weighting of 40%, 40%, and 20%, what's the expected return, variance, and standard deviation? I have taken the liberty of copying all these things into an Excel file so that I was ready to go. This is going to be fairly simple. So let's do the expected return for each stock. Sum product is your friend on this. It is the formula that you will probably use more than anything else on these types of problems. Okay, so we have the expected return in the stock, and then we have the weights, 0.4, 0.4, and 0.2. And if we have the weights and the expected return for each of these stocks, then we can calculate the expected return on the portfolio. Another sum product. .15%, which we see right here. Now, on an earlier module, we used CVS, Microsoft, and Chevron, and we did this exact same calculation. You can see we did a lot of work to get here. We're going to do the shortcut today. The shortcut says that there are 3 possible states of the world: boom, bust, and normal. And it says what is the expected return on the portfolio given these weights in each state of the world. Well, this is a sum product of the weights. I'm going to lock the weights and each state of the world. So we're saying if the boom happens, we have 40% in stock A, and that returns 25%, plus 40% in stock B, and that returns 35%, plus 20% in stock C, and that returns 40%. So we're going to copy that down. Let me wrap this text as well. The deviation from the mean is that minus that. We're going to lock that. I'm going to make this a number. Oops. Squared deviation. You could combine these 2 steps if you would like. Oops. If you would like, you don't have to. And now the variance, oops, and the standard deviation. The variance is going to be the sum product of the different returns and the probability that those returns occur. And the standard deviation is just going to be the square root of that. Let me make this column wider. Let's put this in percent terms. And I want to draw your attention to these 3 numbers. 12.15% is the return, 0.0246 is the variance, and 15.69% is the standard deviation in return. And we can kind of see this. The variance in normal times we get a minus. Oh, I'm sorry, I got this backwards. Oh no, let's make sure. Boom, normal, and bust. Sorry. There we go. 15.9%. So in a bust we get minus 15, and in a boom we get plus 32. So it makes sense that the deviation from that is about 16%. So we get those numbers, and let's answer the last 2 parts of the question. If the expected T-bill rate is 0.38, what is the expected risk premium? So let's just come down here and say I'm just going to copy this down here. 0.038 is the T-bill. Let me make sure I got that right. Yes, okay. So the risk premium is just going to be the return on this portfolio minus the T-bill. And that is the nominal risk premium. Let's drop down a little bit more and say if inflation is 0.035, which is the second part of the question. So we just answered that. What's the expected risk premium? The expected risk premium is 8.35. If inflation is 3.5%, what's the approximate and exact real returns on the portfolio? What are the approximate and exact risk premiums? Okay, so let's do real return. And let's subtract 1 just so we... All right, so recall that we have, for the real rate of return, to adjust for inflation, we do 1 plus the expected return divided by 1 plus the inflation rate. Minus 1 will give you 8.36. Let's see what the real T-bill rate, I'm having trouble typing. That's going to be 1 plus the T-bill rate divided by 1 plus the inflation rate minus 1, and I'm going to put that in percent terms. So that means the real risk premium is going to be the real rate of return minus the real T-bill rate, and I'm going to get rid of all of those decimal places. That was weird. Let's pick a different color. All right, the risk premium nominal is 8.35%, and the risk premium real is 8.07. And the difference here is just that this is a nominal thing and none of these numbers are adjusted for inflation, and this is a real number that is actually adjusted for inflation. The punchline is that the nominal return looks better than the real return, and that's because it doesn't take into account inflation. So you're always going to have less of a return in this setup than you would otherwise. Let's make sure that all of that is